recording, and all we need to do today is to finish off our research. Not a research. All we need to do is to finish off our lectures. So only a couple of slides left. We've covered the stuff that's really at the core of the exam. I've been getting some emails from people who seem to be confused about when the exam is. So please note that the exam timetable has been available since the beginning of the year. So this shouldn't be a mystery to anyone when the exam is. So I can share the screen now. Just give me a sec. So all right, it should be coming through hopefully. So if you take a look at the assessment timetable, and if you look for Computer Science 1, you will see 1B. You'll see it's on the 2nd of November, 12:30. Let me just check that that's right, but the 2nd of November, 12:30 to 15:30, and the venue is, well, it's online. It'll be a Proctorio-based exam like the theory semester test, because we only have permission to do practical tests on campus. So this information has been available to you since, well, at least the date and time have been available since the beginning of the year. I'll put a notice up on Eve, but it's not something that needs to be decided or has it been announced. It's the dates are decided as the year starts, so there's no should be no surprise. And you can see the dates on Ulink. So I'm not sure why people are surprised, but just to clarify, that's it. But then I'm not sure that necessarily some of the people who don't know watch the videos. That being said, there isn't a need for a link for a special code for these last two ones because we're just doing revision. So I wouldn't worry about that. Let me just quickly bring up the lecture slides. No, I didn't mean hide. I actually meant to stop sharing for a moment. I'll reshare in a second. So let's do those last couple of slides, and then we can take a look at past papers. Also in the semester, in the tutorials, we'll be doing past papers as well. All right, yeah, one very important announcement, and it's part of the reason that we've sort of been everyone in the department's been so busy, is that tomorrow is our projects day, all right? And instead of Prac 9, which would have been a regular Prac, but then would have been a VPL Prac, and then would have been so on, we're having a special practical tomorrow during the projects day. You don't have to do any programming or anything like that. It's a bonus assignment where you basically just need to, basically get some information by attending the virtual projects day. So we'll put all the details for that will be in the projects day assignment. You have the whole day to do it. Technically speaking, you could probably get some of the answers that you need after the day is finished, because the website's not going to disappear as the day ends, but rather just do it tomorrow. And yeah, it's an opportunity to improve your mark if you need to do that. All right, so let me bring up slides. I think we got to start sharing again. So yeah, we looked at the different sorting algorithms. There really isn't much left, to be honest. So I'll just recap the sorting algorithms, but we don't need to go into too much detail for them. And share again. Okay. So yeah, let me just answer those questions as well that I can see in the question paper. So in a sense, yeah, tomorrow is a day off, in the sense that there's no tutorials and there's none of the normal academy class events. We're not canceling stuff for maths or your other subjects. I don't know what's going on there, but for us, we have our projects day, and all the staff will be involved in projects day. So no one's going to really be available on Discord or anything like that. There's not going to be any tutorials, but you will have a practical, an extra research day, projects day assignment, which will allow you to pick up some extra marks, and please attend the projects day. So question, all the projects for tomorrow's, are they all web apps? I think that the third year projects have to have a web component to them, as well as normally a mobile component as well. The honors projects are more research focused. Those can be very different. A lot of them are machine learning related and so on. There are other ones, of course, as well, but that's the general focus. So does attendance count? No, it doesn't count towards your final mark. The university just requires us to keep track of attendance. So there's no attendance marks or anything like that. If you talk about, is there attendance marks for projects day, in the sense that you've got an assignment that you can complete and get extra marks for? That's a great question. Actually, yes. So the very best of the second year projects are also at Projects Day. So there's like a handful of second year projects in Projects Day as well. So yes, I think it's the top 4 or something like that. That's a great question. You'll have to look and see. So will be some of your assistants that you will see as well in there. You can see their projects and what they've been doing. So very good questions all around. All right, let's just finish off and remind ourselves about the sorting and searching algorithms that we took a look at. So sorting, it's a very common task, putting things into some sort of order according to some sort of total order property that they have, whether they're greater than, less than, or equal to their neighbors. You can compare them with those variety of metrics that we discussed. I think the key take home for a sorting algorithm, or to understand them, is that sorting is really difficult. But you can sometimes break sorting up into smaller operations that are simple, that if you repeat multiple times, will bring the entire collection into a sorted state. So insertion sort is built around the observation that sorting an entire list from scratch is difficult, but putting one item into its correct position in a sorted list is really easy. So all it does is it repeatedly applies that operation until a big list is sorted, by starting off with a very small list or portion of the list that's sorted, i.e. literally the first item. One item is sorted, and then growing that sorted portion, and then basically taking the new item that gets pulled in and inserting it into its correct location in the sorted portion of the list, and repeating that operation until eventually the sorted portion grows and encompasses the entire list. Most of these have big O(n) squared complexity, which is not great, but that's unfortunately life with these simple algorithms. There's only 2 algorithms that we look at which have better performance, but they're not the easy ones. Selection sort as well. Sorting is difficult, but putting the smallest thing in the first position is easy. So finding a minimum is much easier than sorting a list. So all that selection sort does is it's built on the observation that, well, if we're sorting a list in ascending order, the smallest item must be in position 1. So if we start the loop and we're looking at position 1, search through the remainder of the list, find the smallest item and put it in position 1. Then move forward to position 2. Search through the remainder of the list, find the smallest item and put it in position 2. Move forward 1. Search through the remainder of the list, find the smallest value, put it in position 3, move forward, and keep going. So the way in which they put in the right positions, they get swapped. So the wrong thing that's in the current position gets swapped with the now smallest thing that should be in that position, and you simply repeat that operation multiple times until the list is now sorted. It's terrible, big O of n squared. Merge sort's the first one that's not terrible in the sense that it's got a better time complexity, but it's worse in the sense that it takes up quite a lot of extra memory. It's built on the observation that sorting is difficult, but merging sorted lists is easy. And merging super small lists, i.e. list of size 2, is even easier because you just need to compare the 2 items you've got and put the bigger one on top under the small one, or however it is you're sorting it. So if you repeatedly take your big list up, split it up into smaller and smaller sublists until you've eventually got sublists of size 2, put those two items in the right place, and then let recursion handle the unwinding of everything, you've basically got a sorting algorithm that can sort very efficiently, except it wastes a lot of memory because every copy of the list, every split subcopy of the list sits there in memory in the stack activation frame as the algorithm runs. So its performance is big O of n log n, which will sit in between big O of n and big O of n squared. But it's certainly, you won't find a sorting algorithm that'll be big O of n. That's impossible because that's the cost of just switching. But it's certainly a lot better than big O of n squared. So we're pretty happy with that as a performance. You won't have to know the derivation or know how to work out logarithmic time algorithms in first year, but you will do it a lot in third year. Then bubble sorting is also super easy, also super terrible performance, but it's built on the observation that sorting is hard, but comparing adjacent items and seeing that they're in the right place is easy. So all you do is you could repeatedly loop through the list, compare items that are right next to each other, see if they're in the right position, swap them if they're not, and then if you've swapped, make a note that you swapped that turn, and then you keep going until you don't swap anything. When you don't swap anything, the list is sorted. It's not good because even though it's big O of n squared, it's actually kind of worse big O of n squared than some of the other algorithms because at most each item can only move one step closer to its correct position at each hop, whereas with something like at each iteration, with something like, let's say, um, insertion sort, you're going to always be growing the sorted portion of the list every turn. With selection sort, you're always going to be putting one item in its absolute correct position as you progress. Whereas with bubble sort, they just very slowly move to the right location. So that's that. And quicksort is the best of the sort of normal sorting algorithms that you'll encounter. There are specialized sorting algorithms that, let's say, only work on integers or only work on very certain circumstances which can perform better. But a sort of general purpose sorting algorithm, quicksort, is one of the better ones. And it's a little bit harder to understand, but the basic idea is if you've got a list of items and you pick a sort of pivot item, like an item within the list, if the list was sorted, everything that was less than that pivot item should be to the left of it, and everything that's bigger than that pivot item should be to the right of it. So just repeatedly split the list into halves, picking pivot items and making sure everything's either to the left or to the right of that pivot item based on its size. I suppose you could also group all the things that are exactly equal to the pivot item as well. Then you just join everything together. So you can see it's also not super efficient in this sense because it's actually got double recursion. But there are special implementations of quicksort, and you'll learn one in well, it's not really quicksort, but you'll learn an algorithm called heap sort, which has similar space or speed complexity, which can be implemented as an in-place algorithm. Remember what that means? It's an algorithm that doesn't take extra space while it runs. So I suppose of the algorithms you'll encounter, you know, sort of general purpose ones, one of the better ones you'll see is heap sort, which you'll do in third year. But quicksort works very well. Most built, and there are in-place versions of it as well, and most of the build libraries will probably be using some version of quicksort. And in reality, if you're doing your algorithms yourself in production environments, you shouldn't be implementing sorting from scratch. You should be using the built-in sorting functionality in your libraries. So for example, C++ has got a sort operation that works on collections like vectors. You simply sort from the beginning to the end using those two iterator returning member functions. And if you particularly want, you can even specify a custom comparison function as well. So that will really sort most of your needs out. Searching, so that's basically looking for something. We've seen it many times with the with the linked lists. If you're searching, it means with a linear search, it means start at the beginning and keep going through each item in the list one at a time until you either reach the end of the list or you find the item. So needless to say, its performance is big of n, because worst case scenario is when the item's not there or when it's the very last item. So that's that. Can you do better than a linear search? And the answer is actually yes. What you can do is you can have a situation where if the list is pre-sorted, you can skip checking a lot of the list. So basically what you do is if you're searching for the item, you can check at the beginning. And if it's not there, you can check halfway through the list. And then you see where you're at that halfway point. If the item you're looking for is bigger than the than the item at the midpoint, then you only need to search the top half of the list. If it's less than the item at the midpoint, you only need to search the bottom half of the list. Then you can repeatedly call binary search on the top half and bottom half of the list until eventually it will either find the item or terminate, having the item not being there. And what's nice about that is it means you can skip a large chunk of the list because you know that it's only going to be in the top half or the bottom half of what's left, based on where you are. But the cost is that the data collection has to be pre-sorted. So something that's very useful to do is if you're going to be searching through data a lot, it's sometimes worth the computational cost of pre-sorting the data so that you can save a lot in the future by making your searching cheaper. And they call that trick of doing an expensive operation once early if it pays off in the long run. They call that amortizing the cost of the operation. And you'll see that again a lot in third year, where certain data structures will be inefficient if you only use them once. But if you keep using them repeatedly, then the cost of that initial slow operation will pay off over time. So it's a very useful way of proving the effectiveness of some of the more complicated techniques computationally. And there's no need to really prove anything about it, but it's got a logarithmic time as well. Let me just check here now. Oopsie, sorry, if there are any questions. So this is an excellent question. So do you code look at the space or do you code look at the speed? And that really depends on what you're doing. So firstly, it's a great question for two reasons. One, it's you can do the analysis that we did for calculating speed. You can do that using space as well. All you need to do is basically look at the data that gets used in your algorithm. Let's take a look at, let's say, just anything like this code over here. And okay, you just basically assume that every data type takes the largest amount of space that any one data type takes. And you can then count how many allocations there are. So here we've got an allocation 1. Or you could go for the vector itself, empty, 1, 2, 3, 4, 5, 6 for the loop control variable. So you can work out whether a number n, which instead of being the time complexity, you can then have it be the space complexity. And then the question was, which is best to work out or to optimize for, space versus speed? And because both would be expensive and difficult to do. That's exactly right. You very rarely get a situation where you can get an increase in both space and speed. So sometimes you need to make that decision based on the environment you're operating in. So if you're operating in like a small constrained memory environment, like a embedded device or a cell phone or something like that, then you will optimize for space, even if the algorithms are slower. But again, those things also tend to have pretty slow CPUs, so you can't lean too far towards slowness as well. So it is a balancing act. Very, very good point. They call it the space-speed trade-off because you often have to swap a little bit of space for a bit of speed. Over here, isn't there a factor of the device that impacts speed? So lots. So for one thing, the CPU. But another thing is sometimes even an algorithm that uses a lot of memory can wind up being slow because what will happen is you run out of RAM and then your data gets swapped to the hard through a process called virtual RAM, which then is slower than normal RAM. So even if you optimize too much in favor of a fast memory and efficient algorithm, you can wind up slowing the whole thing down because it runs out of memory. So there are no real easy answers to these questions. It's always a trade-off and an engineering decision you have to make about where the balance is. So really great question. Also need to consider your program. Yeah, sharing for virtual machines and cloud environments also bring in a literal cost environment, cost component to these decisions as well. If you're paying for CPU usage, that it becomes a big issue, as well as if you're sharing resources with the team, you have to factor that in. So these are really some very good observations. Historically, this has been true, because historically, sort of CPU growth has been slower than storage if we include particularly long-term storage. But it's not always going to be the case. So I'd say yes, but it's not a rule we can make for all time. You have to look at the situation for your particular context and make a decision. So games will typically focus on speed, and they have for a long time, because storage is cheap. So you'll notice games have been getting very big. It's, load stuff into memory and process it quickly. Obviously, if you have enough memory or enough video memory is the issue. If you run out, things will be very bad. But I don't think they've been focusing too much on optimizing for space with computer games recently. But then again, there are exceptions. Apparently, Doom was optimized very well in terms of those things. So it does depend. I'm talking very broadly. If you want to look at a very, very interesting thing, it's called K. Krieger, and it's written quite a long time ago now, but it's a couple of 100 kilobytes big, and it's a full 3D shooter game. Obviously, it looks really old now. But the whole point is that they try to squeeze as much into as little space as possible. It's part of a constrained programming challenge. So K. Krieger, it's something that's worth looking up. And then the relationship between space and speed is also often, it's normally a triangle of space, speed, and cost. And you sort of have to sacrifice one or two to get the other one. So fast and large at the cost of being expensive, or something else. So typically that's the triangle of things you need to. Are they inversely proportional? I don't think it's strictly inverse, but it's definitely, yes, I'd say it's inverse, but not a linear relationship. You get a sudden collapse of space and speed at either end of the boundary. So largely inversely proportional, weakly inversely proportional. But what homework? So no, the homework, you'll be given an assignment tomorrow for you to complete in projects day. You don't have to do it; it's bonus marks, but it's always good to try and increase your bonus marks. Okay, Krieger, that's what I was thinking of. Oh, okay. Oh, lol. All right. Anyway. All right, so I think that's that. Let me just stop sharing for a moment, and then I'll open up a past paper. Just give me a sec. So I was working on a past paper in the tutorial, but not the second one. So that was the 2020 main paper. So I think we can carry on from there. So you can watch the other parts of it in the videos. Okay, let me reshare. All right, here we go. So I can't quite remember where we got to. I think we answered. Oh, it was the 2019 paper I was doing. Sorry, my bad. 2019 main paper. Yes, and I think, yeah, we got to the end of this. We got to the file handling question. So let's carry on with that. All right, so a lot of you'll see that these questions are often not too dissimilar. There's a couple of variants that you get. Story will be different, but what you need to do doesn't fundamentally change that much. So effectively, you can be asked to read from a text file where each line of text has a fixed number of items, or read from a text file where each line of text has a variable number of items, or write to a text file, or read from a binary file of records, or write to a binary file of records, or write to a specific record in a binary file of records, or calculate the size of a binary file of records. That's about it, really. So if you know how to do those things, you should definitely be getting all the marks for question 3, because all that will really vary is the number of variables and their types that you need, and to know which of the various operations you need to do. So here, for example, is a question that deals with fleet telemetry, so tracking of vehicles, but you don't really need to know that. It's got a file format where there's the epoch time, license, latitude, longitude, odometer reading, speedometer reading, fuel, and the end of line. So it tells you what these means. Epoch time is the integer number of seconds since 1st of January 1970. Lat and long are real, indicating where the vehicle was. License is the registration number as a white space free string. Odo and fuel are integers representing distance and fuel reserve percentage, respectively. EOL is end of line. So now it says write a function, code for a function, which will find and print the license numbers of all vehicles with fuel levels below 25% after a given epoch time. So the actual core logic that you need to work with is actually very simple, and most of the marks come from the file handling. So don't let the questions you should be easily getting these marks. So let's see, what would this one look like? We need, firstly, we need to open the file. So it's a string file, a text file, so it'll be if stream. Right, let's just call it F, and there's no special need to do anything weird with it. So we just specify the name, telemetry, and now it's opened. And the first time you say close the file, you'll also get a mark. So if you forget to do it in question 3.1, we will give you the closing marks in later questions, but you won't get a mark for closing every time you do it. So don't think you can say, oh, I'm going to close the file and nothing else for 3.1, 3.2, 3.3, and so on, and rack up like 3 or 4 or 5 points. That's not going to work. Only the first time you do it do you get the mark. But if you don't do it, you're throwing away a mark. All right, so now what do we need to do? We need to read in this data. So it was an integer for the epoch time. I'm not going to have these amazing names. I'm just going to call them E for epoch. And we needed also the fuel and the speed. Those were emails. Those were integers as well. We needed a string for the license value. Lazy, just call that L. And then we also needed the latitude and the longitude. Those were real numbers, I think. Yeah, so then double lat and long. Right, and then we need to do the actual work of reading through every, odometer as well. Where was the odometer? Oh, we didn't actually mention speed there. Whoops. Oh well, assume it's an integer. And odometer. Let's read everything in. Actually, if we don't know what it is, the correct assumption is just to read it in as a string, because we're not processing it in any way, so it doesn't actually matter. So it's fine. So all we need to do then is loop from F, stream that into the epoch value, into the license value, into the lat value, into the long value, into the odometer value, into the speed value, and into the fuel value. And if you can assume that the file is well formatted, and you don't have to handle like corrupted files or anything like that. Certainly not for a 5-mark theory question. And then we've got those values, and we can do what we need to do with them. So all we need to do is, it says, check whether the fuel levels are below 25% and after a given epoch time. So let's say that there's some input to this. I don't know, after or whatever. You could do it as a function as well, but I'm just reading it in. So now we're saying if the epoch is after, and if the fuel value is below 25%, then we must output the license value. And that's it. End of story. So it's not that complicated. And then just also in terms of where the marks come from, most of the marks will come from here, and declaring the variables that make sense, and here, and then closing it. So this logic isn't going to be worth that much. So if you mess it up, don't worry. Most of the marks come from the file handling stuff, like the question very clearly says. All right, let's see if there were any questions about that. So we're busy marking it. So it's quite a lot, as well as there was quite a large SIG test. So you will have your marks by Friday. No, it doesn't actually. No, so there's no marks for that. So don't worry about it. We're interested in the core of it. So you don't have to worry about giving a good function name and blah blah blah. Just give us the details. In fact, yeah. So I suppose it does ask for a function. Strictly speaking, sorry, I didn't read that properly. But we definitely wouldn't take any marks away for not doing it in a function. That's not what we're interested in. We're interested in the file handling. If this were a question about functions, then that's what we'd worry about. All right, define a structure with alignment packing disabled to represent data for one vehicle. Okay, so for one of these, but we need to know more details because we've got strings. So with strings, we can't represent them as the C++ string type. We have to represent them as char arrays so that they have a fixed size. So, and that you need as much precision as possible to store the real numbers. So basically, let's break this up. So structure with packing alignment. Most of your marks will come from things like disabling the packing alignment. So there's no reason for anyone to not be getting like 3 out of 5 for this question. Then what do we need to know? We need to know size of the string, so it's 8 characters. And what this means is that we need to use doubles rather than floats for our real numbers. So it's quite easy. Let's simply do it. Okay, so it'll be struct, but let's get our marks for disabling the packing alignment. So pragma pack, save the old value, push, pragma pack, set the value to its lowest possible value, packing alignment to 1 byte boundaries basically. At the end, set it to its old value. In vehicle, and then we just need to declare those things in the right order. So it was an integer epoch, and then what else? License, that's a string, but it's not just any string, it's a char, whatever, L of size 8. And what else did we have? Latitude and longitude, which were double. So double lat. Okay. Double long. And then the odometer reading, which was an integer, I believe. Yeah, so int odo. And then the speed, which we didn't specify, so let's just, but then we make a size for it. So for this one, it's a bit trickier. So yeah, we'd have to accept anything for this, but I'm just going to make the speed have a size 8 as well. And then fuel, we said was a percentage. And fuel, oopsie. And that's it. So again, where does most of the marks come from? So 1, 2, 3, and then the remaining 2 marks come from what you've done inside there. And as I said, because we didn't specify the speed actually explicitly, we'd accept anything for your speed variable. I suppose technically, even if you left it out, we would give you the mark for it. All right, let's see. Is there any questions? Okay. No, so there's no attendance codes for the remaining 2 lectures because we're just doing revision. So don't worry about it. If I declared latitude as float, half a mark at most, to be honest. but because the question does explicitly say maximum precision, so that is a double. But yeah, maximum half a mark. Okay, that's a good. So can I explain the pragma codes? Excellent. Let me do that. So what do they mean? So in memory, when we load a structure, right? Let's say our structure has some sort of binary pattern that represents the actual values of the stuff inside it. That's literally what happens when you make a struct. A struct is that each of these gets represented in binary based on their size. So this will be 8 bytes big. This will be however big your integer word size is, and your floating point IEEE. I think that's 32-bit or 64-bit binary sequences. So basically, all of these get converted into their binary representations and stacked next to each other, one after each other, in the order that they appear here. And arrays obviously just get duplicated. But your operating system isn't going to work with it like that, right? Because it's more efficient for the operating system to read and write in certain fixed size chunks. So they call those chunks words. So they want those words to align up to specific nice even binary number boundaries, like 32-bit boundaries or 64-bit boundaries and so on. So what will happen is it's just going to add extra zeros, either at the beginning or sometimes even in between various data members in your structure to make things line up neatly in memory, just so it can read and write them in like blocks, basically, and do it more efficiently. So it's not a problem internally while you're just programming, because the programming language will handle, and the runtime will handle all of that complexity. It becomes an issue, though, when you convert stuff into binary data and write it to a file, because then if you read it back on a different system, right, the extra padding zeros that have been added are going to mess everything up. So you can turn this off, right? And basically what you're doing here is you're backing up the old alignment information. So push means add to the top of a stack, right? So we're going to store the old packing alignment. And what I mean by packing alignment is just basically how many zeros need to be added, and store that somewhere. Then on a stack. Then reset the current packing value to be 1. That's the smallest value it can be. It means align on 1 byte boundaries, which basically means add no zeros at any point in time. Then we have our structure, which just gets defined as per normal. And then we basically say, once you're done with that structure, restore the old alignment values, because they're there for a reason. They do make things more efficient. But it's just for anything that needs to be read and written to the hard disk as a sequence of binary values. We want that behavior to be turned off for. So it just basically disables it for this one particular data structure. So very good question. Hopefully that helped. Yeah, we are done with the lecture notes. There are no more lecture notes. When would you use floats? Look, I mean, they're smaller and less precise than doubles. So I suspect that things like multiplication with floats is cheaper for the CPU to do. So if you don't care too much about precision, then floats are fine. But if you're doing something where like being off by a few decimal places could cause a big problem, then it's safer to use doubles. So it depends what you're doing. Like if it's just going to cause like a little bit of a slight discoloration, if you're doing some like graphics calculations, is it such a big deal? No, you'll probably wind up using floats then because they're quicker. But if you're doing like an engineering system where the spacecraft is going to either crash or not crash, then it is a bigger deal. I still don't have an answer. It's a really good question. Sorry, I will message the HOD and ask just for final clarification. So at the moment, our feedback is study as if the book is not open, but if the test is not open. But it might be, but please don't assume anything. So rather assume no and just study like crazy. And then if it turns out to be open book, all the better. So what does Pragma do? It basically, look, Pragmas are a variety of like non-standard instructions. So basically what this is saying is it's saying this is a non-standard C++ preprocessor instruction. They're called pragmas. The actual name of the pragma is pack. So think of it as running a compile time function that's not really standard, but most compilers will support this. Now they have added better alignment management stuff to C++ 20, I think they started to add even in 17 and so on. So we might switch over to that in the future, away from the pragmas for portability's sake. But for now, this is the one that works best on the widest variety of systems. So that's what hashtag pragma means. It means run a non-standard compile time bit of functionality. Yes, that's perfect understanding. Exactly right. Okay, you know what? That's a really good point. Is there such a thing as a long double? To be perfectly honest, I'm not 100% sure, but if there might be, good grief. If so, then you are 100% correct, and that would be even better. I suppose you might actually have an excellent point. Of the data types we use in the module, double is the one with the best position, but are there others that might have even better? Well, I mean, yeah, you could even use a decimal class that stores everything as strings and calculates everything to arbitrary precision. So point taken, that's a good observation. All right, if we had to use it would be even impossible to read from a file because you don't know where those extra zeros have been added into the structure. So if you know exactly where they've been added, you could always write very convoluted code to remove them. But it just makes it much less portable. No, it's for both reading and writing because you need the alignment needs to match from the writer to the reader. If there's a mismatch, then there's going to be binary values going into the wrong variables, as it were. So it's for both. So this is an excellent question. Go through past papers. The upcoming papers are not going to be a deviation in terms of their structure. Obviously, the questions will be different, but will you be asked a bunch of file handling questions? Yes. In fact, they will even be in the same position in the paper worth the same amount of marks. Obviously, the exact questions will be different. Will you be asked an analysis question? Yes, you will. Obviously, the code will be different. Will you be asked DLL stuff at the end? Yes, you will. But the exact operations you need to do for the DLL will be different. So the structure, the scope is the same as previous years. So working through past papers is the right thing to do. Obviously, the exact questions will be different. The exact diagram you need to draw for UML and so on will all vary. But the best thing you can do to study is to work through past papers. So that is a great question. That's why I give you past papers back to the dawn of time. Okay, the past paper is the same length as the others. So let's look together. Okay, actually, that doesn't. It's 2 hours. However, because you will be doing it remotely via Proctorio, you will get extra time for uploading and for sorting out your Proctorio issues, just like with the second semester test. So you'll have at least, let's say, an extra hour or so to handle those issues. So that's a good question. All right, I think we're out of time now, if I'm not mistaken, or pretty close to it. So I think I'm going to wrap up there. But thank you very much, and that's that. Have a good afternoon. See you at Projects Day. Please check E for your Projects Day assignment. So the practice tests, it's not a bad idea, to be honest. I will upload a practice test again for you in Proctorio. You still have access to the practice module on Proctorio. That hasn't gone anyway, so you can still check that. But purely for practice test on Proctorio, I'll do one for you as well. Okay, just remind me. Yeah. Yeah. No, so that's a good idea. Thank you. I will set one up for you. You can come to Projects Day, to Campus Projects Day all you want. It's a virtual event, so there's not going to be anyone there, right? It's a purely virtual event. But if you want to access the stuff from the campus hardware and network, go for it. The actual judging of the teams is on Discord, and the rest of it's just a website. Is it compulsory? No, it's not compulsory. It's bonus marks if you want them. Yes, there is a bonus marks assignment. Yes, you can watch the judging, but you join the teams meetings as non-speakers. So you can't speak, but you can. The judges can speak, and the teams can speak as well. Okay. All right. Thanks, everyone. I wish you well. Have a good evening.